Right. Now essentially in the structure what I have is two restraints here and one restraint here. So three restraints, so three support reactions I have. Right. And how many members do we have? How many internal member forces do we have? 1, 2, 3, 4, 5, 6, 7. So 7 members are there. So 3 plus 7 is equal to 10 are the number of unknowns that I have for this truss structure. Right. And how many equations of equilibrium do we have? For each node I have two equations of equilibrium, namely summation of fx is equal to 0, summation of fy is equal to 0. So for 5, 1, 2, 3, 4, 5, so for 5 nodes what we have is 5 into 2, that is 10 equations of equilibrium. And as there are 10 unknowns and 10 equations of equilibrium, we can solve all these unknown forces. And essentially this will be a case of a determinate structure. Now, the unknowns are classified into two categories. Number one, you have the external support reactions, that is 2 here and 1 here. And then you have 7 unknown member forces that are essentially acting here, 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 here. So there are 7 unknown member forces and we call it the internal member forces, and 3 support reactions, and they are together amalgamated to quantify the number of unknowns we have, that is 10. And 3 and 10 are the number of equations of equilibrium that we have. So this is a case of a statically determinate structure. Now let us see that whether we can make this structure statically indeterminate. Right. We can make the structure statically indeterminate in 2 ways. Right. Number one, we can replace this roller support by, say, a hinge support. And if I replace this roller support by a hinge support, then essentially how many support reactions will I have? 2 plus 2, that is equal to 4. So I will have 4 support reactions if I replace this roller support by a hinge support, and 7 unknown member forces. So 4 plus 7 is equal to 11 unknowns and 10 equations of equilibrium. So I cannot solve out all the unknowns just by using the equations of equilibrium, and this is a case of a statically indeterminate structure. Right. So here we can convert the statically indeterminate structure to some sort of a statically indeterminate structure if we can remove one of this redundant support reaction. Right. If you can remove one of the redundant support reactions, essentially equilibrium won't be altered. Right. There will be equilibrium. Right. So essentially we can make the structure statically determinate from statically indeterminate just by removing a redundant support reaction or an internal member force. Now let us go back to the previous structure, that is a hinge and a roller. Right. So here is one restraint, so this is 10, so this is then a statically determinate structure. Now in the previous case what we did was we replaced this roller support by a hinge support, and then we made the structure statically indeterminate. We can also make the structure statically indeterminate by increasing one of its member. For example, let us have a member like this. Then what I have is 3 support reactions and 8 members, that is 11 unknowns again, and essentially 10 equations of equilibrium. So it's a statically indeterminate structure again. So we can make the structure statically indeterminate either by increasing the support reaction more than necessary, or by increasing the internal members. So if the indeterminacy that we get here the indeterminacy that we get is because we have one extra member. So this is a case of internal indeterminacy, and the previous case we had the indeterminate structure resulting from a hinge support here. So that was a case of external indeterminacy. Right. So external indeterminacy means that just by using the equations of equilibrium we'll not be able to find out all the external support reactions. And internal indeterminacy means that just by using the equations of equilibrium we won't be able to find out all the internal member unknown forces. So I think this is all for this lecture, and in this lecture what I've looked at is basically I've given a brief overview of what is determinate structure, what is indeterminate structure, what do you mean by external indeterminacy, what do you mean by internal indeterminacy, and see you in the next lecture.